When we face a crisis, it's kind of in our DNA to build something. We engineer bridges, we create vaccines, we just find a way. But what happens when the crisis is the entire planet? So in this explainer, we're going to ask a really big question. Can we actually engineer our way out of climate change?
So take a look at this. This image is known as the warming stripes. It's simple, but wow, is it powerful. Each stripe represents a single year, shifting from cool blues to fiery reds. And altogether, well, it paints a pretty undeniable picture of our planet's rising fever, all driven by human activity.
And this isn't just some abstract trend, it's real. The World Meteorological Organization just confirmed that in 2024, the planet was about 1.55 degrees Celsius warmer than it was before the industrial age. Now, that number isn't just a new record. It's a critical line that scientists have been warning us about for years. And yeah, we've crossed it.
Which brings us right back to our core question. We are problem solvers, right? It's what we do. But is our engineering skill, our ingenuity, really powerful enough to go up against something as huge as the entire global climate? Let's take a look at the tools we actually have in our toolkit.
Okay, so our first line of defense isn't actually about stopping climate change itself. It's about surviving it. This is what we call the adaptation toolkit, all the strategies we're using to get ready for the impacts that are either already happening or, let's be honest, are definitely on their way.
So what does that actually look like in the real world? Well, we're building higher seawalls and stronger levees. We're coming up with amazing drought-tolerant crops and super smart irrigation that can slash water use by up to 60%. In our cities, we're doing things like planting more trees and putting cool roofs on buildings to bring down the heat. And we're also creating early warning systems to help save lives. It's this really interesting mix of heavy-duty engineering and just smarter social planning.
And here's the most important part. This stuff works. It really does. Investing in defenses before disaster strikes is incredibly effective. One analysis found that being proactive like this cuts the projected damages by an order of magnitude. Basically, it turns what could be hundreds of billions in losses into tens of billions. A huge difference.
But, and this is a really big but, adaptation has its limits. The IPCC has been super clear about this. You can build the world's best seawall, but a powerful enough storm can still blow right past it. And some things, like our beautiful coral reefs, you just can't adapt them to oceans that are getting warmer and more acidic. So while adaptation is absolutely essential, it can't be our only answer, not by a long shot. All right, so if adapting on the ground isn't enough, what about going bigger? What about trying to engineer the atmosphere itself? Now we're getting into the really high-tech and, frankly, highly controversial frontier of climate solutions. First up, there's something called carbon dioxide removal, or CDR. It's exactly what it sounds like, figuring out ways to pull CO2 right out of the air. This can be as low-tech as planting a forest or as wildly futuristic as building these giant machines for direct air capture. The IPCC says we'll actually need some form of this to hit our goals. The only problem, right now, the high-tech versions are really small scale and incredibly expensive.
Then there's the even more radical idea, solar geoengineering. The whole idea here isn't to get rid of the CO2, but to treat the symptom, which is the heat. It's like creating a temporary artificial sunshade for the entire planet, just reflecting a tiny bit of sunlight back out into space. So how would that even work? Well, the basic idea is pretty straightforward. You'd inject these tiny reflective particles, like sulfur aerosols, way up into the stratosphere. They'd scatter the sunlight, less heat would reach the ground, and in theory, global temperatures could drop pretty fast. It's like trying to install a thermostat for the whole planet.
It sounds like something straight out of science fiction, right? A quick fix? But whenever we talk about a technology this powerful, we have to ask the most important question there is. What could possibly go wrong?
And whoa, that list of potential risks is long, and it's pretty sobering. You could mess with the ozone layer, you could shift rain patterns and cause droughts or floods somewhere else. It does absolutely nothing for ocean acidification, which is another huge CO2 problem. Then you have the geopolitical nightmare. Who controls this global thermostat? And maybe the scariest of all is something called termination shock. If you ever stop, the planet could experience decades worth of warming in just a few years.
So yeah, these big engineering ideas come with massive technical and ethical question marks, but they also come with a price tag. And that brings us to the really crucial issues of economics and equity. Who pays for survival, and is that fair? Let's start with the good news here. Investing in adaptation, it pays off. Big time. The return on investment is just remarkable. The UN estimates that for every single dollar you spend on something like coastal flood defenses, you save about $14 in damages you don't have to deal with later. I mean, that's just a fantastic deal.
But here's the problem. The money just isn't there, especially for the people who need it most. This chart shows you the huge gap between what developing nations need for adaptation, we're talking over $215 billion a year, and what they actually get, which is closer to $21 billion. The UN is calling this an adaptation emergency. Ultimately, the economic argument boils down to something really simple and really stark. All the analysis has shown for years that investing about 1 to 2% of global GDP right now to cut emissions and adapt is way, way cheaper than paying for the damages later on. Action is an investment, plain and simple. It is not a cost.
Okay, so after looking at adaptation, these high-tech ideas, and the economics of it all, one thing becomes crystal clear. There is no single silver bullet. There's no one invention that's going to magically fix everything. So, what does the realistic path forward actually look like?
The consensus from pretty much all the experts is that these incredible techno-fixes can only ever be a supplement. They are not a replacement for doing the hard work of getting our emissions down to net zero. We simply cannot engineer our way out of a problem while we're still pouring fuel on the fire. So the balanced strategy, the one scientists recommend, is really a three-pronged approach. First, mitigation. We have to aggressively cut emissions right at the source. That's number one. Second, adaptation. Build up our resilience to protect people from the changes that are already locked in. And third, innovation. Cautiously, and I mean cautiously, research new technologies, understanding both their incredible promise and their potential peril. Which kind of leaves us with this final thought. The very same human ingenuity that powered the Industrial Revolution, the thing that created this crisis, well, now we're calling on it to solve it. It's a powerful and maybe a little ironic thought to end on. Our ability to build and innovate is both the source of the problem and maybe, just maybe, our best hope for finding a way through it.